Section 4, I want to similarly rapidly take you through the ketoses here. So remember, a ketose has a carbonyl or a ketone at carbon 2. And so this here featured on the screen would be the triketose. And it barely qualifies as a monosaccharide because it has the correct chemical formula. It has a OH group on the bottom carbon of the chain. It's got a ketone and has a OH on the top carbon. So it's not D or L because there's no stereogenic center. This molecule is completely achiral, and we sometimes call it dihydroxyacetone, okay? And that's that, all right? I believe this is used in tanning. Isn't it a tanning additive? Anyways, let's keep on going. So this right here is 1, 2, 3, 4 carbons. So this would be a ketopentoses. Okay. And there's only one D ketopentoses that you can possibly draw, and the name of this is D-erythrulose. And the reason why there's not a different D sugar is because if we flip this, we would get the L sugar. So that's not a D sugar. So there's 0 stereogenic centers. So if we do 2 to the nth, right, 2 to the 0 power is equal to just 1. All right, so there's one molecule we can possibly draw for this. All right. On the screen here, we have 1, 2, 3, 4, 5. So these are ketopentoses. So again, remember there's a ketone at carbon 2. There's 5 total carbons, and this is a sugar, so we end the name with -ose. On the left, we have D-ribulose, and on the right, we have D-xylulose. It's really hard to pronounce these sugar names. We have one stereogenic center that can vary, okay, if we want to maintain a D sugar. So there's one stereogenic center there that we're varying. So 2 to the nth, where n is equal to 1, so 2 to the first is equal to 2. Okay, so there's 2 molecules here for the ketopentoses, all right? Here are the hexopentoses. So there's 6 total carbons. There's a ketone and there's sugar, so they end in -ose. So these are all keto. Hexoses, if I can spell that correctly. Okay. And there's a total of 2 stereogenic centers. So 2 to the nth is equal, so n is equal to 2. So 2 squared is, 4. So there's 4 molecules here, okay? The 2 OHs could both be to the right, both to the left, or variabilities in between. And they're all D sugars, so we can't change that blue hydroxyl group. So all of these are naturally occurring, produced by various fungi, bacteria, so on and so forth, okay? So these are D-psychose, D-fructose, D-sorbose, and D-tagatose, all right? And that's it for the ketoses. Let's go ahead and do some more interesting chemistry now.